Okay, so we want to start out with a review of our areas here. The assignment I gave you, the pre-assignment I gave you to work on, dealt with rectangles, parallelograms, and maybe a little bit of triangles, trapezoids and stuff like that. Anything that had that rectangular shape or four-sided shape to it. But anyway, just kind of a little bit of a development of what area is. When we're dealing with geometry, everything starts from the most basic geometric shape. That right there. It's called a point. And all it is a location. From that, everything else is constructed. For example, we can take that point and we can pull it in a single direction. And what we have created is a line segment. Now, the name line segment isn't nearly as important as what it creates. It creates a length. The length that it creates is equal to the distance that that point had moved. So you can see in reality, length and distance are the same concept. So once we've created that line segment, we can create another more complex geometric shape. Right now, it started out as a point with 0 dimensions. After we pull it in a single direction, it has 1 dimension. We can now create a third dimension by taking it and pulling it in a second direction. If we pull it in that direction, if you think of like having a stick and pulling it across the sand or a dusty table or whatever, it traces out a rectangle. Now that second direction has to be what we call perpendicular. In other words, at a right angle to the original direction. And what we have created here is an area. And the size of that area is related to that original length, the distance of the first move of the point, times this new distance that we moved, which is equal to a width. Or that we call it a width. We name it the width. So area is a length times a distance, or a length times a width. So for a rectangle, if this is 12 inches and this is 5 inches, the area, 12 inches times 5 inches. Well, 12 times 5 is 60. Inches times inches is square inches. The reason I define areas in this manner is it applies to a lot of other things as well. Let's say we start out with that same 12-inch length. And this time I pull it, but it's not perpendicular. But as I pull it, the stick stays parallel to its original orientation. It doesn't twist or anything in the process. Pretend those all look parallel. Well, as long as the distance between where it started and where it stopped is still 5 inches, the area of this is still going to be 60 inches squared. Think of it this way. Think of this as being a bunch of rectangles stacked up. Really thin rectangles. Well, this is the same rectangles. They've just been slid off to the side a little bit. Like that. It's the same area. The end of these rectangles still has the same area. They've just been slid over one way or another. Or like a stack of papers. If you have a stack of papers and you push the top over, the side's still the same size. It just, part of it moved over a little bit. So that area is still going to be 12 inches times 5 inches, or 60 square inches. In fact, and most people have seen this part before. And of course, the big thing here is you got to have this measurement here, not this one. That one doesn't mean anything. It's that perpendicular distance between where the side started and where it stopped. Now, the part that a lot of people have never seen before is this. If this is 12 inches again, and now instead of moving it in a straight line or whatever, we move it, but we're still keeping it parallel to its original orientation. And let's say we pull it like this. So now we've got that same shape. This is still 12 inches. And let's say that from here to here is still 5 inches. What's its area? Still 60 square inches. And again, it's because you can think of the end of this as being a bunch of those little rectangles stacked up. It doesn't matter how they're pushed off to the side and how they're arranged. The area of all those rectangles still adds up to the same total area. By the way, that's kind of the basic concept of calculus, is you divide something up into rectangles that are so small you can rearrange them and change the shape, but it doesn't change the area. We're not going to get into calculus in here, but just kind of a little foreshadowing for you. So then what about a triangle? We're going to start out with a right triangle with a right angle in it. If that's 12 inches and this is 5 inches, to find its area, we can think of it as being a rectangle. And that rectangle, of course, would be 12 inches by 5 inches. But it's not, the triangle doesn't fill up the full rectangle, it actually is half. So divided by 2, that's going to be 30 square inches. So it's either the base times the height divided by 2, or in some cases, 1/2 times the base times height, depending on what you're used to. I like to keep the same formula and just divide it by 2 because it's half of that original rectangle. And of course, it's not always a right triangle. It could look like this, where this is 12 inches, this being 5 inches. It is still half of that whole rectangle. This part's half of this part's half of this piece. It is still 30 square inches. Okay, so on to the next more complicated step. Trapezoids. A trapezoid is just a figure. The definition of a trapezoid is it's a four-sided figure where one set of opposite sides are parallel. So here, these two sides are parallel. And usually what we're given is the length of the two parallel sides are called bases. We're given the length of those bases. So that's 18 inches and 32 inches. And some sort of a distance between the bases. And that distance, as always, has to be perpendicular, just like with everything else we did. Like up here, this 5 inches had to be perpendicular to the base. Area always involves two dimensions that are perpendicular to each other. So let's say that dimension is 16 inches. To find the area of this, just like we did with the triangle and everything else, we turn it into a rectangle. I'm going to go halfway down the side. I'm going to chop this off at a right angle. If I flip this up, it should exactly fill in this missing piece. So I've squared off that end of it. I'll do the same over here. Go halfway down, chop this off, flip it up, and I've squared off that end. So now what we have here is a rectangle. Its height is still 16. Its length, however, is somewhere between the 18 and the 32. In fact, it is exactly between. It's the average of the 18 and 32. So you average the 18 and 32. Average the two bases, in other words, and then multiply by the height. Well, 18 plus 32 is 50, divided by 2 is 25, times 16 is 400 inches squared. So the area of that is 400 square inches. Those formulas all look familiar? Okay. Pretend that's perpendicular. So how would I find the area of this? What are my two bases, first of all? 12 and 30. So 12 plus 30 divided by 2, average those together, times 20. So 42 divided by 2 is 21, times 20 is 420. So that's pretty much all of our shapes. Now we have composite shapes where we combine, triangles and rectangles together. A lot of times even just combining rectangles. Like this. So in something like this, there's two ways to approach it. I can cut it like this into two small rectangles. I have one here that is 8 by 6 or 48 square feet. And I have this one is 18 by 14. Because you have to take the 20 minus the 6, right? This is 14 over here. 18 by 14, otherwise known as 252 square feet. That adds up to 300 square feet. The other way I could have done it is this. I could have filled this in and said that's 18 by 20, which is 360 square feet. And then said there's a piece here that's missing, however, that is 6 feet by 10 feet, which is 60 square feet. Subtracting would give us 300 square feet. Notice we get the same answer either way. In this problem, it's about the same amount of work to do it either way. But on some of the ones you're doing in your homework, there may be problems where it's easier to add on and make it a full rectangle and subtract out missing pieces. For example, something like this. Wow, that's ugly. Yeah, we'll try it. So what's that give me across there? 46. So 6. That's got to go. Something like this to find the area of it. If I try to chop this into smaller rectangles, I mean, I'm going to be doing a lot of chopping. It's going to get ugly, and I got to find missing dimensions. But if I were to, oops, that's not what I wanted. Get back here. If I were to extend this out and make it a large rectangle, I've got 24 and 22 makes it 46 total that way. Hopefully the other ones add up to the same. And going this way, I've got 18 total. So I could find a whole rectangle that is 46 by 18. I'll pull up the calculator for that one. Let's try that again. 828. And of course, whatever units those are, if those are inches, it's square inches, if it's feet, it's square feet, whatever. And then I'm going to subtract out each of these little pieces. This one is 8 by 6. That's minus 48, so that's 780. This one's 2 by 10, so that's minus 20, so that's 760. This one's 4 by 22, which is 88. So subtract that out, that is 672. What do you think? English? That's good. The next step in the level of difficulty, circles. I always got to remember that projector distorts things. That looks round on my screen. When we deal with circles, there are a couple of features that define a circle. The biggest one is a radius. It's the distance from the center out. Now we have other features, something called a chord. Just connects any two parts of a circle. Well, that chord can be all sorts of different lengths. What we're most concerned with is a very special chord that goes through the center of a circle. Any chord that goes through the center of the circle is called a diameter. The relationship, the diameter is equal to 2 times the radius. Of course, we also have the circumference. Circumference is the perimeter, or the distance around the circle. The circumference of a circle is pi times the diameter. Pi is a mathematical constant that is 3.14159, blah, blah, blah. Bless you. You have a, bless you again. You have a pi key on your calculator that you can use if you want to. I generally just use 3.14 in class so I can calculate in my head a little bit easier. But that's fine. The circumference is either the diameter times pi or pi times diameter, or it can also be thought of as 2 times the radius times pi, or usually written as 2 times pi times the radius, like that. So if I have a circle, has a radius of 4 feet. The circumference will be 2 times 3.14 times 4, which is approximately 25.12 feet. Make sense? So what if I have a circle that has a diameter of 10 inches? What's its circumference going to be? Well, 3.14 pi times 10, or 31.4 inches. Make sense? On quizzes and tests, by the way, I'll figure out the answer both ways. I will have it written using 3.14 and with using the pi key. So if you use the pi key, it'll be slightly different on some of these. Area of a circle. Anybody know the formula for the area of a circle? Involves pi times radius squared, pi r squared. So back up to one of these circles, this first one here, radius of 4, its area would be pi times 4 squared. Well, 4 squared is 16 times pi is 50.24. And that'll be square feet. This one here, the area is going to be pi times not 10 squared, but 5 squared. So pi times 25 is approximately 78.5, and that'll be inches squared, square inches. Looking familiar? So, you need to be able to apply these formulas in the right spot. You might need to be able to combine them. We'll look at some things with circles here in a second for combining them. The big question is, where does that formula come from? Deriving the formula for the area of a circle is really not as tough as it looks. I'm going to have a circle, and I'm just going to call its radius r. What I'm going to do is I'm going to cut that circle in half. What would the circumference of that whole circle, of course, is 2 times pi times r, right? Well, what would be the distance around half of that circle then? Divided by 2, you cancel out the 2. This is just pi times r, right? Pi r. So I'm going to take that half circle, I'm going to cut it into really thin slices. As thin a slices as I can cut. And I'm going to fan it out. Like that. And then what I'm going to do is I'm going to cut the other half of the circle in equally thin slices. I'm going to fan them out and slide them in like this to fill in that gap. If I cut them thin enough, this is approximately a rectangle. This here is just the radius of the circle, right? This, if I cut them thin enough that's almost a straight line, is just this distance, pi times r. We have a rectangle that is pi r times r, which is pi r squared. I mean, I'm not going to ever ask you to do that, but it's just kind of interesting to see where the formula comes from. We will run into questions that might look something like this. There you go. It's the lane in the basketball hoop. Find the area. Well, yeah, we're going to cut it into a rectangle. Piece 1 there is a rectangle that is 10 by 16, 160 square feet. Then that half circle, pi times, what's its radius? 5. Yeah, 10 is the diameter, 5 will be the radius. So pi times 5 squared divided by 2, which ends up being 39.25. We add those together to get 199.25 square feet. What do you think? Gets a little trickier. You might run into ones like this. Find the area of this. Now here's one we're going to have to subtract. We find the area of the whole thing, which is 20 by 16, or 320 inches square inches. Now for this, we need to know, pretend that looks like a circle. If that were a full circle, what would its radius be? 8 inches, good. So we know this has got to be 8 inches this way too. Doesn't matter, but if we were trying to find this dimension, we'd be able to find it from that. So that area is pi times 8 squared divided by 4, because it's only a fourth of a circle, which is 50.24 square inches. Subtracting gives us 269.76 square inches of area. What do y'all think? I've done this a few times before. Don't worry, it's not contagious. Math is about patterns. Once you start seeing the patterns underneath it, the calculations are really simple. Yeah, we got to remember, I've done this. I've done this pretty much every day of my life for like 19 years now. So hopefully I've seen them. Otherwise, I'd be on top of the building with a shotgun when you guys walked in the morning, ready to take everybody out. Shoot, I still had that recording when I said that. Dang it. So anyway, I had given you the page 585 through 589, problems 1 through 49, the odds. If you haven't finished those up, make sure you understand them at least. Page 601 through 603, 1 through 31, the odds, has the circles and stuff in them. Now, I don't know if I mentioned this on Monday at all or not, but I'm not going to go through and grade your homework. So if you're doing it and the first few seem easy, go ahead and skip ahead to the more difficult ones. Make sure you know how to do them. If you're comfortable doing a quiz on it that might come up like by Friday, then I'm okay with it. I'm not going to knock you down if you don't do all your homework. If you already know how to do it, I don't want you to sit there and do busy work doing the stuff over again that you already know how to do. Any questions? Okay, so you'll have your last 15 minutes.